Welcome to Survey Matters with Duncan-Parnell. My name is Mark White and I'm the Training and Support Manager for DP. Today I want to talk to you guys about a subject that just keeps coming up over and over again throughout the years that I've been here, and that is grid and ground coordinates. What are they and how does Trimble Access and Trimble Business Center handle the difference between grid and ground coordinates? But before we get started, please like and subscribe. Okay, so grid and ground coordinates, like I said, this is a subject that comes up in our support queue a lot. People asking about how to set up Trimble Access or set up Trimble Business Center to be able to work with coordinates that are in a grid system or get ground distances while they're working in a grid system, right? And some people don't even know there's a difference, okay? That comes up every now and then too. There's also a misunderstanding that the type of sensor you're using in the field matters. Like if I'm using a total station, I'm going to get ground distances. If I'm using GPS, I'm going to get grid distances. There's some myths there as well that we need to understand how the software works so that we can use it properly, all right? And so like I said, this comes up a lot, so I wanted to do a video on it. I did a webinar with Trimble, I think it was back in 2017, that's on our YouTube channel too, that you can go back and watch. But this is just gonna be a little bit shorter video, just a refresher on how it works, and really hoping to get across how the software handles your data, okay? That's the most important thing. So I started surveying about 35 years ago. Yes, the gray hair is real. And back then, GNSS, before GNSS came out and was used widely, grid and ground coordinates weren't that big of a deal. People didn't worry about it. They didn't talk about it because back then we were pretty much using total stations for everything, all right? And a total station measures a horizontal ground distance in and of itself, right? So we were using mostly total stations and we were using assumed coordinates. Now, towards the beginning of my career, the first 5 years of my career, is when GPS started coming out and guys started doing static with it. And every company had that GPS guy, but kind of what he did was like black box voodoo stuff. You really didn't know what was going on with it. Nobody asked any questions about it, right? And then the VRS network started coming out in the early 2000s. Base Rover RTK really started getting popular 20 plus years ago. And when we started using GPS, all of a sudden we had to start working in real world coordinate systems, right? Because GPS uses Earth-centered or fixed coordinates that then get converted to latitudes and longitudes. And then as surveyors, we usually want to project that into some sort of coordinate system, all right? So, next slide. Coordinate systems or datums are all based on an ellipsoid. An ellipsoid is just a mathematical model of the world, okay? Just something that's a best fit for the shape of the Earth. And since the Earth spins, it bulges at the equator, so we use an ellipse instead of a circle. So it's a little bit shorter at the poles, a little bit wider at the equator. Now, I'm in the United States, so we use the U.S. State Plane Coordinate System, and it's 2026 right now. We're getting ready to update our coordinate system, so this is going to change a little bit, but as things stand now, we use the GRS 80 ellipsoid. So ellipsoids do their measurements using latitudes and longitudes, all right? Like I said, satellites use Earth-centered or fixed coordinates. Then we convert that into a latitude and longitude based on whatever coordinate system we're using. And you could go ahead and map in latitude and longitude and height, right? Some people do that. But surveyors, we like the math to be a little bit easier. So we like to flatten it out and do our work on a flat plane or a grid and use northings, eastings, and elevations because it's just easier to do the math on a flat surface, right? Now I'm going to keep this pretty basic. We're not going to get into super detail about how this all works, but I want you guys to have a basic understanding of what's going on here. So then when we look at the settings in the software, you'll have a better idea why you're setting things the way you're setting them, right? So a datum's going to use an ellipsoid. That's a round surface. We want it flat. So what we do is we project that round surface to a flat surface. Now in the US, we mainly use the transverse Mercator projection for states that are longer north-south, and we use the Lambert conformal projection for states that are longer east-west. Now the transverse Mercator is just a cylindrical projection. The Lambert conformal is a conical projection. So you see here, I've got pictures of transverse Mercator. It's a cylinder. Lambert conformal is a cone. Now what we're actually doing with that, and I'm in North Carolina, we're longer east-west, so we use a Lambert conformal. So I'm going to show you some pictures that use that cone. And this comes from a book that was written by the head of the North Carolina Geodetic Survey, a guy named Gary Thompson. I will leave a link for the PDF of this in the description here. Awesome book, really helped me understand how a coordinate system works, in this case state plane, but it's called Development and Application of the State Coordinate System, and it covers North Carolina, but it's applicable for all coordinate systems and how they work, right? So we use this cone to project the round surface into a flat one, and what we do is we take that cone and we slide it over the round surface, okay? If you're using transverse Mercator, you're going to take that tube and slide it over. And you see there where the cone crosses, it's basically cutting out a piece of that round surface. And there's certain sizes that we use to keep the distortion at a minimum. So we're only cutting off a small amount. That's why some states have multiple zones to them, right? Because of the size of the state. So we take a cone and we slice off a piece of the circle, or we take a cylinder and we slice off a piece of a circle. Now the World Cup's going on right now. It's June of 2026. And, you know, think about taking a soccer ball and slicing off a piece of it, putting it on this table and pressing it flat. There's going to be some distortion, right? It's not going to flatten out perfectly. But that's what we're doing when we do this with a coordinate system. We slice off a piece of the circle and then we unfold it, like here's the cone unfolded, but there's going to be a little bit of distortion here, right? So we see in this picture that the scale's too small in between the two standard parallels, or where we sliced the circle off. The scale's too small there and the scale's too large outside of them, all right? So when we flatten it out, we're getting distortion that's too small in the middle, distortion that's too large on the outside. Now that's gonna vary depending on what kind of projection you're using. But just know that there is distortion, and we use scale factors to account for the differences in that distortion. So here's how it looks in North Carolina. I slice off a piece of North Carolina, and again, those standard parallels at the top and the bottom there, or just inside the top and the bottom, the scale's exact at that standard parallel because that's where the cone is touching the ellipsoid. So there's no scaling going on there. But since we're flattening out that rounded surface in the middle, the scale, it's got to come down. The scale's too small there, and we're flattening up on the outside. The scale's too large on the outside, all right? Here's a great picture of what's happening here. And this is the picture when I saw this in the book that Gary and another guy, Joe Scott at the North Carolina Survey, also was involved in this. The book they wrote, when I saw this picture, the light bulb went off for me, okay? Because as surveyors, you see we've got a ground surface, we got that ellipsoid surface, and then we've got the grid plane, right? We survey up there on the ground, right? So we've got 2 points here, 2 points over there. And when we plumb our rod, theoretically, I'm not going to get into all the ins and outs of this, but theoretically, we plumb it to the center of the earth, right? And so we can see there, I've got a measurement, those plumb lines going down to the center of the earth. And you'll see I get one distance on the ground, I get another distance on the ellipsoid, and I get yet a third distance down there on the grid plane, right? So I get a ground distance, an ellipsoid distance, and a grid distance. And depending on where I am, it might be longer on the grid or shorter on the grid, right? When I get outside that parallel on the one side, you'll see it's actually a little bit longer on the grid. If I'm inside, it's usually going to be longer on the ground. All right, so you're going to see some scale factors that are above 1, some scale factors that are below 1. So again, I measure here with my GPS or my total station and my rod. I get a ground distance, I get an ellipsoid distance, then I get a grid distance. And if I'm inside those parallels, ground's longer, ellipsoid's a little bit shorter, state plane grid, or if you're not in North America and you're not using US state plane, whatever coordinate system grid you're using, if you're inside the parallels there, it's going to be a little bit shorter. Outside the parallels, it's going to be a little bit longer. Now what we do is we use scale factors to account for those differences, right? So there's my 3 distances. I got D1 on the ground, D2 on the ellipsoid, D3 on the grid. So I use an elevation factor, or the difference between the ground and the ellipsoid, to make up that difference. So that's one scale factor that I use. And then some softwares call it a grid factor. USGS on their data sheets calls it the scale factor, to then reduce the amount from the ellipsoid down to the grid. So 2 different scale factors. Elevation factor, so it does matter how high you are. And then scale factor, it depends on where you are on the round surface as to how much scaling is going on there, right? So those 2 factors. Now, I take those 2 factors and I combine them, and that's what we're used to seeing as surveyors, is a combined scale factor. If I take the elevation factor, multiply it times the scale factor or the grid factor, that creates what's called a combined factor. A combined factor will scale us from the ground down to grid. If I inverse that amount, it will scale me from grid to ground, okay? That's an important concept to have, because that's what we're doing in our software, whether it's in the data collector or on our computer. A lot of times we'll go out and collect stuff in grid, but we want ground distances because we're surveying on the ground, so we need to know how to properly scale that data, right? And we need to understand how the software is doing it, because some people have misconceptions about that. All right, so there's 2 main distances to scale from grid to ground. The first one is scaling distances, and this is how most people do it nowadays. The other one is scaling coordinates, okay? To scale a distance, you hold 1 point fixed in the software, so grid and ground is equal at that 1 point. You apply the inverse of the combined factor, because we're going from grid to ground, and then all the distances away from that point that's held fixed, those distances get scaled, so the coordinates get scaled proportionally away from that 1 point. All right, that's how a lot of softwares do it. That's how Trimble Access does it. That's how TBC does it. That's how a lot of DOTs do it, because that minimalizes the distortion amount in the coordinates, right? The other way is you can scale your coordinates. You can take that inverse of the combined factor, and you can multiply the northing and multiply the easting of all your coordinates. And then if you inverse between those scaled coordinates, you'll actually get the correct ground distance. So that's another way. The only problem with that is it kind of shifts your coordinates by a larger amount, and sometimes that can cause issues in mapping. So scaling distances keeps the coordinates closer to their true value. Scaling coordinates still works, just changes the coordinate values by a decent amount. All right, so again, Access and TBC scale distances. The key thing to understand, and I can't emphasize this enough, this is where most people get confused. Grid is grid and ground is ground, all right? When I set up my software, if I set the settings to grid, I'm getting grid distances. Everything's being scaled to grid. If I set it to ground, everything's being set to ground. It doesn't matter what sensor I'm using. A lot of people have the misconception out there that if I use a total station, then my software is giving me ground distances, because a total station measures a horizontal ground distance. Then they think, well, if I'm using GPS, GPS is always giving me grid, just because in their mind, back in the old days, that's how we did everything, right? We set it up in a state plane system because we had to use real coordinates, so it was on grid. But I want to show you guys how the software actually works. If I set the software to use grid, it doesn't matter if I'm using a total station or I'm using GPS. I'm going to get grid distances. The software is going to take care of that for me. If I set it to ground, everything's going to be on ground. Doesn't matter if I'm using a total station or GPS. The software is going to take care of it. The beautiful thing about that is you don't have to have multiple jobs. Some people will do one job with their GPS on grid, one job with their total station on something like a scale of 1, and then they get mismatched data and don't understand why it doesn't work together, right? This way you can set it to grid and you get grid. Use whatever sensor you want. Set it to ground, you get ground. Use whatever sensor you want, right? So now let's take a look at Trimble Access and Trimble Business Center and how they actually do that and how to set it up properly. Okay, so I've got Trimble Access opened up, got it here. This is 2026.10, so there's a little bit different setup in the project and job that you might see. So I'm in the project screen. I'll go ahead and create a new project. I'm just going to call it GG for grid and ground. Now you'll notice here that there's some properties in 2026.10. What this allows you to do is set your units and your coordinate system for the project, and then any jobs you create default to these settings, okay? So if you have an older version, you just basically set the project up and it didn't have that information in it as far as units and coordinate system and feature library and all that. That was just in the job properties, all right? So no matter where you set it up here in the project properties or job properties, it looks the same, and we'll take a look at both, right? So GG, I'm gonna go units. I am still in a US survey foot state for now. When things change, the end of this year, next year, we'll go to international feet or imperial, but right now we're survey feet, so I'm gonna use survey feet. And now let's take a look at our coordinate system, okay? I'm gonna set it to select from library. I'm using United States NAT 83. Again, I'm in North Carolina, so I'll just switch it over to my state, North Carolina 3200. Now, as I come down, I am using a geoid model. All right, that gives me good sea level or geoid elevations there. Now, this is the key, okay? If your job is set to grid, you are getting grid coordinates. Even if you hook up to a total station, the total station is measuring horizontal ground distances, but the software is doing what I just showed you, okay? Reduce to the ellipsoid, reduce to the grid, and you're getting grid distances, all right? Doesn't matter what sensor you're using. You're using GPS, if it's set to grid, you're getting grid. You use a total station, set to grid, you're getting grid. Now you have a couple other options where you have a ground keyed in scale factor or a ground calculated scale factor. If I choose one of those, if it's set to ground, I'm getting ground, okay? For a ground calculated scale factor, I can choose a point out of the job. This is a brand new job, so there's no points in there, but if I go shoot a control point, come back into my settings, I could choose that. Otherwise, I could put in the latitude, the longitude, the height, or I could put in the northing, easting, and elevation if I change it over to grid coordinates, and it's going to calculate a ground scale factor for me, and that's the inverse of the combined factor. All right. Now, if I had that information already, I could go to ground keyed in scale factor and I could just key in the scale factor. I still have to key in the northing, easting, and elevation or the lat, lon, and height because I need that location for the scaling to come from. You'll see there's an option to scale from the project location or grid 00. With state plane, you want to use or most known coordinate systems, you want to use a project location. Otherwise, if you go all the way to 00, it's going to blow your scaling out of the water. So you're scaling from the project location. So if you key in, you put in the scale factor you were given, or the inverse of it to go to ground, right? The inverse of the combined factor and the location. Or if you've got a point in the job, you can shoot that point, come down here. Again, I got a new job. I'm in the office today, don't have a point in here, but I could go to point and it'll automatically fill that in for me and calculate that ground scale factor, which will show up right here, okay? So that is how you would do it in here. Just the key thing, the takeaway that I can't emphasize enough is if your job is set to ground, you're getting ground coordinates no matter what sensor you hook up to. If it's set to grid, you're getting grid coordinates no matter what sensor you're hooked up to, all right? Then I just store that and I'll put in a project height. I could store that and I'm good to go there. Now I'm set to grid, right? It says North Carolina 3200, NAT 83. I could create that. let me escape real quick and I'll show you one that is set up for ground from another project. So this test 2 was actually done on ground coordinates. So if I look at the properties of this, you'll see it's North Carolina 3200 and it says ground next to it, okay? If it just says your coordinate system and it doesn't say ground, you're in grid. If it says ground, it's letting you know you're in ground. And if I click on that, you'll see I've got a project location here and I've got a scale factor, and that scale factor is 1.00010. So about 1/10 of a foot of difference for every 1,000 feet I go there, all right? So just know that's how much it is scaling in this location where this particular job was. But that's what you're gonna see there, okay? Key thing, guys, I can't emphasize it enough. Grid is grid, ground is ground, right? It really is that simple. I love Trimble Access for that simplicity. So now let's take a look at Trimble Business Center and how a local site works in TBC. Okay, so I've got TBC open. I've got some RTK data in here, a couple of base stations set up, shooting some property corners. Now, if I look at the very bottom of the screen down there, it's kind of small, but at the bottom of the screen, it says US survey foot, grid, North Carolina 3200. If it says grid on the screen there, then I'm working in grid coordinates, right? If I have a known coordinate system next to it. Okay, so if it says grid, North Carolina 3200, grid UTM 18, grid, let's say Virginia South, whatever. If it has a known coordinate system and it says grid next to it, you are working in grid coordinates, all right? Doesn't matter if it's total station data, doesn't matter if it's GPS data. Now, if I go to my settings up here at the top, click settings, and I'll look at my coordinate system, we can see here that everything is set up in state plane coordinates, same thing I had on the data collector there, right? But then if I go to local site is where I would set my ground coordinates up. You'll see there's no location for the local site. Now you see the ground scale factor set to 1 and it says use ground coordinates is no. All right, so again, if you just want to check and make sure whether you're in grid or ground in TBC, at the bottom it's going to give you an idea. This is going to 100% tell you that you're in grid coordinates because it says no for ground, right? Now, if I wanted to set up ground coordinates in TBC, so I'm at grid now, if I wanted to change the ground, I can click on this button for local site settings. It's going to open up a menu where I can do grid, local, or global. That's just, do I want to use a northing and easting? Do I want to use a local Latin line or a global Latin line? I'll keep it on northing and easting. And I can go out here and I can select one of my points, like point number 1, select the elevation there for point number 1. Now you notice it gives you options to select the northing and easting, and then it makes you select the elevation as well. And that's because you want to make sure you're using an elevation that best fits your site. If you're on a really steep site, you don't want to use the highest or the lowest. You want to kind of use something in the middle, because remember, that elevation factor is part of your combined factor, so you don't want to skew things. You wanted a good balanced elevation. This is a pretty flat site, so I'll just choose the elevation there. But this gives you the chance to put in a mean elevation if you need to, all right? So I've selected my location just like I would in Access. I tell it I want to use ground coordinates, and I tell it that I want it to compute the ground scale factor. So again, I could key one in if I wanted to and use that location and key one in, or I can have the software do it for me. So now you'll see I've got 1.00087, so about just under 900ths per 1,000 feet at this project location. I could put in a false northing and a false easting if I wanted to, and you could have done this in Access too. I didn't cover it. But this way, you can make it look like it's not state plane coordinates, right? You could truncate it by like 500,000, so when people look at it, they'll know, whoa, this isn't state plane, just to kind of differentiate between grid and ground coordinates, right? So I'm going to leave that at 0, but you could do that. Now, if I click OK here, it's going to update all these points. Now, one's going to be held grid and ground equal. All the other points just got scaled. The distance they are away from point number 1 by that combined factor, they got scaled. And now at the bottom, it'll say US survey foot, ground, North Carolina 3200. And if I go back to my settings and look at local site, it says use ground coordinates, yes, and it tells me what my factor is there, okay? And again, remember, it doesn't matter what you're using. It doesn't matter if it's total station or if it's grid. If it says ground on here, I'm using ground. If it says grid, I'm using grid. So if you collect things in the field and grid, but you want to scale into ground in the office, you can do that. Or maybe if the field crew did it in ground and you want a grid, you can bring it into TBC and you can uncheck that box and it'll recompute the data and put it on grid for you, okay? So guys, that's just a quick tour of it. I hope that helps everybody understand. Again, the key takeaway for this is, and the thing that makes Trimble software so easy to use, in my opinion, is it doesn't matter what sensor you're using. So I can mix GPS and robot data in the same job. I just have to scale it accordingly, okay? And now I didn't bring this up in Trimble Access, but you do want to kind of choose a point that's central to the job to scale from. I don't want to pick a point that's like 10 miles away from my job, right? Because I want a scale factor to be computed that is at my job site. So like in this example, I chose point number 1. I could have calculated a point in the middle if this was a large site and just used a calculated point. It doesn't have to be one of your control points. Most guys are going to scale from one of their control points, but it doesn't have to be. It's just math at the end of the day. So you could create a central point and use that. You just want to make sure you have a point that's representative of your site and an elevation that's representative of your site, okay? So that those scale factors that are calculated are representative of your site, all right? And just remember, grid is grid, ground is ground. Well, guys, I appreciate you stopping by today for Survey Matters, and we'll see you on the next one.